Let's finish this module with a demo. We'll create a simple resource manager plan. Let's come back to SQL Developer and walk through this code to show you what it looks like. In lines 9 through 12, we're giving the Scott user the ability, the delegated administration to do resource plans. And you just tap in, you execute DBMS Resource Manager privs, grant system privilege to a particular user. And of course, admin option means that Scott would be able to delegate other administrators this same privilege. Now, this test case that I'm about to show you is adapted from a really cool IBM.com tutorial. Here's the link here. And what this does is it creates a consumer group called reporting group that's going to get very heavily restricted CPU access. So first, alter system set resource manager plan to null. This disables any current resource plan. Makes sense, right? We're setting an initialization parameter to null. Then, just by way of setup, you know, when you work through somebody's script, they normally have a cleanup area first here where we're dropping the resource plan and consumer groups that might have been created during testing here if I've already done this. I haven't, so I'm just going to skip through that and we'll get right into this. When you're creating an advanced resource plan, you create a workspace area called a pending area. Just consider it scratch space that gets populated with your plan, and then at the end of the process, you submit the pending area. You validate the pending area, and then you submit that to commit all of your changes to the server. So once you've created the pending area, we can go ahead and create our group. So we're creating a consumer group. You'll notice that all of these are methods underneath DBMS Resource Manager. This is really your one-stop shop for doing Resource Manager programmatically. Consumer group is reporting group, and then the comment just describes it. Now we're going to create a plan. We'll call this plan daytime. Presumably, we can plug this plan in with Oracle Scheduler to be the automatic active plan during the daytime hours, right? What directives or rules are we including here? Well, we're saying here for the sys group, which we know is the built-in administrators group, they have access to 100% of the CPU. If you've done firewall rules, you know how this works. You want to make sure that admins don't get caught inadvertently with restrictions. And you also want to make sure that other groups, in other words, people who aren't explicitly hit by another one of your directives, they don't fall through the cracks. In the second directive, we're giving reporting group 5% of the CPU. And then the catch-all for other groups, we're giving them basically anything left over on the CPU. What else do we need to do besides creating the consumer group and creating the plan and creating the directives? Of course, we have to populate that daytime reporting group. It looks like in this sample code, we're going to do 3 static mappings such that 3 users, report 1, report 2, and report 3, get populated into that reporting group. And notice that when you do group mapping, you have to validate and submit the pending area as well. And then the final step here is to run an alter system set, resource manager plan, and then put that plan into effect. Well, I've just selected all of those lines and submitted them. I didn't get any errors back, so we can switch over to Cloud Control to quickly take a look at the results, and I'll show you the monitoring interface as well. From the Database Resource Manager page, let's jump right over to Plans, and we can see that our daytime plan is created and is active. Let's give it a click and we can take a look at what it looks like. The interface allows us to change the description. We can activate or deactivate the active plan. We can deactivate automatic plan switching if we want to override and keep this as an active plan regardless of what the scheduler windows are doing. As far as resource allocations are concerned, this is what we specified. At level 1, there's sysgroup that has full access to the CPU. Anything that the sysgroup is not using CPU-wise bleeds over to level 2, where reporting group is capped at 5%. As long as reporting group isn't using any, actually, even if they are using their 5%, that's such a low percentage, it should bleed over to level 3, and then anybody else here gets any CPU that's left over. Now, in this simple example, we're just doing CPU utilization, but understand that we're able to access a lot more than just CPU when we create one of these plans. Let's go back to Resource Manager, and let me take you to Performance Statistics. This is where we can graphically get a picture of what's happening with our system. Number one, it shows us the active resource plan, and this is hyperlinked. Gives us a list of CPUs per server, CPUs used per instance. And this is important. I'll mention this briefly. Instance caging comes into effect when you have more than one database instance on the same server. Let's say you have a dual socket server and you have two instances of Oracle database. Instance caging means that each of those instances would have exclusive access to one processor. What if you had 4 processors and you wanted to give 3 to one instance and 1 to another? You would configure instance caging to take care of that. Unfortunately, it looks like my interface has crashed. I'm getting some Java errors here, but I just want to show you that you can see at a glance what the current utilization is and the utilization limit for your different groups. And then, like I said, if you've done directives for parallelism and session limit, timeouts, and all that kind of stuff, you can get that metadata from here as well. Alternatively, there are views like DBA _ RSRC _ plans. There's _ consumer groups _ plan directives. There's lots of administrative DBA views that allow you to monitor Resource Manager programmatically as well.